11.8 The Gas Laws. Charles Law. Absolute zero and temperature scale. Lord Kelvin experimented with a variety of gases, graphing their volumes at various temperatures, and noticed that the graphs of all gases intercept the temperature axis at the same point. This implied that the volume of every gas would become zero at a temperature of 273.15 degrees Celsius. Now this temperature is very important. This temperature is called absolute zero. This is the theoretical temperature at which the entities of a material contain no kinetic energy and therefore transmit no thermal energy. And it's equal to negative 273.15 degrees Celsius. The Kelvin temperature scale is a temperature scale that includes absolute zero and the same sized unit divisions as the Celsius temperature scale. Absolute temperature is a measurement of the average kinetic energy of the entities of a substance, and the unit symbol is K. Let's learn how to convert from Celsius to Kelvin. Standard temperature is defined at 25 degrees Celsius. Convert this temperature to absolute temperature. Absolute temperature is equal to the temperature in degrees Celsius plus 273, where capital T is absolute temperature measured in Kelvin, and T is temperature measured in degrees Celsius. To find the absolute temperature, it's equal to 25 degrees Celsius plus 273. So the absolute temperature of 25 degrees Celsius is 298 Kelvin. Charles Law. Volume and temperature of a gas are directly proportionate. This relationship between the volume of gases and the temperature was developed by a French scientist named Jacques Charles from 1746 to 1823. Charles determined that the volume of a gas increases as its temperature increases proportionally, provided that the pressure on the amount of gas remains constant. Keep this in mind. The one caveat that is present is that during these experiments, the pressure of the gas is constant. Charles' law can be expressed as an equation. V1 over T1 equals V2 over T2. The volume of a gas is directly proportional to its temperature in Kelvin, provided the pressure and the amount of gas remains constant. Let's look at temperature and volume. A sample of gas is drawn into a piston. If the sample occupies 0.255 liters at 25 degrees Celsius, what volume will the gas occupy if it's heated to 80 degrees Celsius? The pressure and amount of gas are kept constant throughout the process. Step 1. Let's convert the temperatures T1, 25 degrees Celsius, and T2, 80 degrees Celsius. Let's convert them into Kelvin. That equals 25 degrees plus 273. That is 298 Kelvin. 80 degrees plus 273 equals 353 Kelvin. Next, let's rearrange Charles' law to isolate the unknown variable. We have V1, 0.255 liters, T1, 298 Kelvin, T2, 353 Kelvin, and V2 is what we're looking for. Charles' law states that V1 over T1 equals V2 over T2, and we need to solve for V2. We're going to multiply both sides by T2. They will cancel out, and we are left with V2 equals V1 T2 over T1. Let's sub in our values and determine the final volume. If we punch this into our calculator, we end up with a volume of 0.300 liters. Therefore, the volume of gas at 80 degrees Celsius is 0.300 liters. Please try any practice problems assigned in this section. Read over the textbook for this section and answer any questions on the LMS that were assigned.